Okay. Excuse my kids singing Frozen in the background while we do this. But apparently the videos can only go 15 minutes. Now I know. So, we left off with just noticeable difference, and I went to talk about Weber's Law when I got cut off. So, Weber's Law is the explanation of how different things have to be to meet the just noticeable difference or the difference threshold. So, it's not about specific like numbers per se. So I was just talking about using the example of weight. If I have two weights in my hand, how much do they have to be different by before I notice? So if I have a 1 pound weight in each hand and then I add a pound to one of those blindly, like somebody puts another pound onto one, would I be able to tell the difference? Absolutely, because now one is twice as heavy as the other, right? It just gained 100% mass. Versus if I was super strong and had two 50-pound dumbbells or whatever here, and then I added a pound to one of them, would I be able to tell which one was heavier? No, because they're both really heavy. They're both 50 pounds. Now one's 51, but it doesn't feel a difference. So we can't say like, oh, in terms of when we've noticed the weight is different on something, add a pound. That doesn't work. If we're adding a pound to a pound, yeah, that's doubling the weight. If we're adding 1 pound to 50 pounds, it doesn't really matter. So Weber's Law talks about how it has to be a percentage or a proportion difference between two things before we notice. It's not about a specific amount, like how brighter. It's proportion-wise. So let's see. Why are we flipping here? There we go. So it's the same with like if we talked about like money, which I guess I don't have on this one. When you buy a new car or you're buying a car and let's say like the car's $5,000 used, and then they say that's great, $5,000, but we're going to have to tag on another $1,000 for like fees and paperwork. You're like, oh my God, no, that's like 20% of the price of the car. No way. But if I'm buying like a house and it's $100,000 and they say we have to tag on $1,000 for the paperwork, yeah, go ahead. It's whatever. Like it's not even a big deal. So it's all about proportion wise or percentage wise. All right. Let me see if I want to do this or not. So sure, we can talk about this stuff. Why not? We're in a crowded room and it's super noisy and there's lots of people talking and you're trying really hard to focus on the conversation that your friend is having with you. Since all your focus is there, you're going to ignore a lot of other things around you because it's noisy. You said none of this stuff is important. I'm going to focus on just what my friend is saying because your brain is determining what is the most important thing. So this brings in signal detection theory, which is super weird, but I understand why it's here now after all these years of teaching. It's mathematical formulas that you don't need to know, but it basically predicts how people will respond when asked to detect a really, really faint signal. So there is random noise, and then there's the one signal they want you to listen to. And so they want to figure out how do you get people to ignore all the background or the, quote, noise and pick up on that one faint signal, and you just ignore the rest. And so this was developed out of the Cold War because we were really worried about, Russia blowing us up or the Soviet Union blowing us up. So we wanted people to be tested to be like, hey, if you sit here and watch radar, are you going to be able to detect the, missile coming in versus all the other noise that might be on radar or sonar or whatever? And so they were trying to figure out who would be best at it and how you can determine or make people better at it. This assumes that there's no single absolute threshold. So maybe you and I have different absolute thresholds. Maybe I'm better at certain things than you, or you're better at it than me. Who knows? This is saying that we can't say like every single person with perfect vision could see a candle 50% of the time 30 miles away. Maybe not. Maybe some people can see it further. Maybe some people can see it less far, And so they talk about how like there's this box, right? And this is the green is what we want, the hit or the correct rejection. And we want to figure out how to avoid the misses or the false alarms. So you hope that people will say if the signal was present, they say yes, or if the signal was not there, they say nope, I didn't hear anything. You don't want people false reporting or there is a signal and they totally just miss it, right? And so what we figured out was that this can happen in the real world too, not us sitting there waiting for the Soviets to bomb us, but you can get a false positive. So if you've ever thought you saw your friend in a crowd, not a crowd, and you start waving at them, right? And then you realize, oh, wait, that's a stranger. I don't know that person. They just resembled. So that's a false positive. And then a false negative would be that you may not notice directions at the top of a test that instructs you to not write on the test at all, right? Some kids I know said they had teachers that did this, where it said, like, all you have to do is read the directions and sign your name at the top of this test and then sit still. And everyone else feverishly, like, wrote out this test and filled it out and were panicking. And they just sat there because they read the test. A lot of people don't, though, right? They miss that. Could also be the idea of you, like, thinking you have a phone call coming in. And so you're waiting and anticipating and waiting for it. So then you, like, think you heard your phone vibrate or felt it vibrate. Or you thought you heard it ring, but it really didn't. So how do you get people that are going to be super focused, also not over respond? I think I heard it when it wasn't there. How do you get people to just get the nail right on the head? Yes, it's there. No, it wasn't. Perfect score. So what we noticed was it depends on how distinct the stimulus is, how big that signal is. Is it, the brighter the blip or the louder the sound? Obviously, we would be more likely to catch it. Environmental variables. How loud is it where you're at? How much distracting stuff is going on? Are there lights strobing? Are there a bunch of people? Is it loud? Also, are you motivated to catch this? Do you want to catch it, or is it just like, whatever, if I do, I do, if I don't, oh well. So there's a lot of variables that go into you being able to pick up on these things. So signal detection theory just kind of plays off of absolute threshold. Do we have one? Don't we? And either way, how do we be better at picking up stimuluses versus not? All right, so let's make sure I'm where I want. This thing's acting kind of funny. There we go. So sensory adaptation. We're just gonna keep cruising through this one, and then I'll tackle the eye later. Sensory adaptation. The idea that when you're exposed to a stimuli for a really long time, you just kind of get numb or used to it. So the idea that you walk into a room and someone farted, and you smell it at first, and then it stinks real bad, but after a while, you don't even notice anymore. If somebody else walked in the room, they would totally smell it, but you've just been sitting in it for a long time, so you don't smell the stink anymore. Or maybe a nicer example is if you've ever, like, gotten into a pool or the ocean when it's really, really cold, but if you stay in there long enough, you tend to not notice how freezing the water is because you just get used to it. Or you hop in your friend's car, and their music is blaring, and you're like, why do you have it so loud? And they're like, because I like it. And you just sit in the car, and eventually it doesn't seem that loud to you anymore after you're stuck in it for a while. That's sensory adaptation. You just adapt, you get used to it, it diminishes its effects. Another thing we can talk about is selective attention. You have the ability to focus on one thing or be aware of one thing and kind of ignore a lot of other things going on in the distance. So your surroundings, I suppose. So an example of this, it doesn't mean it's a definition of selective attention. Cocktail party effect is like a subset of it. And this is the idea that when you're talking to someone, when you're having a conversation with everyone, if you're like in the school cafeteria or something, you're at a party, you can focus on your friend and you's conversation and ignore all the other conversations going around. That's a cocktail party effect. It's bleeding out or ignoring conversations and being able to focus on one. Selective attention is ignoring all other stimuluses around you and being able to focus on whatever you're doing. So like if you're listening to this lecture right now and you're not paying attention to the movie on in the background or whatever, maybe that's what's going on. You're probably blocking out a lot of things to be paying attention to this. So it brings to the example of divided attention. Can we divide our attention? Can't we? Thing is, no, we can't. Humans are really bad at it. We can't divide our attention at all. You can do one thing well. If you try to do multiple things at once, you'll do both of them very crappy. It's like you have 100% of effort to give, and if you're doing two things at once and trying to multitask, each of them get a percentage of that 100%. You can't give both 100% of your attention. That's not how our brains work. We can do one thing at a time. And so I'll post a video, or maybe we'll do it for Zoom. We'll watch a video of divided attention. Maybe we have in this class. We might have done it already in another chapter. So I'll ask you guys because I can't remember. All right. Let me zoom past this video here. Inattentional blindness is one of my favorite things because it's so much fun. I can't remember if we've done this already. I think we did for your guys' class because we talked about divided attention. Inattentional blindness is the failing to see objects when they're directly in front of you or like within your field of vision. So the idea that something can happen directly in front of you but you don't see it because you're focused on something else. So I don't remember if we watched it or not, so I don't want to give it away, but the idea of the basketball example, which I'll ask you again in our lecture today, but the idea that these people can be playing basketball and you're supposed to count how many times the players in white pass the ball to each other, and you need to get the answer right. So you're so focused on it that other things happen. They cross directly in front of your path, and you don't even pay attention to it because you're so focused in on just these players in the white shirts passing the balls back and forth. You might miss things that occur directly in your field of vision and go in and out because you're focused on something else. You can also have change blindness. Things actually change right in front of you. So maybe a backdrop changes color, and you don't even notice it by the end of the video because you were so focused on one thing. So this is a really good example. Old man is talking to this gentleman here, and then, a sign came up between them, and now he's still talking to the young man, and he doesn't even notice. That's two different people. But people don't notice because change blind, or inattentional blindness. It just occurs, and we don't even notice. Or in this case, this would be more like change blindness. The person has changed almost in front of you, but you're unaware. It just shows we're pretty unaware of a lot of things that happen in front of us. Now, we're going to... No, we can do schemas. My video might run out. I might have to do a part 3. Schemas are concepts that have formed by your experiences, right? So your schema for a bird, you're going to have like, birds have a beak, wings, feathers, talons. And then when I think about a bird, I might think of like one like here, or like a robin or something, right? So it's how I interpret the world around me. And our schemas create a perceptual set. This is a predisposition to perceiving something in a certain way. So if you look up at a cloud and I say, oh my gosh, what do you see? You can see pictures in a cloud because you're trying to compare it to your schemas you have of objects, right? Things you've seen before. And it looks close enough. That must be what it is. And we're going to play with backmasking today in our Zoom lecture because it's super fun and we play with perceptual sets. Okay, perceptual sets let us detect faces and things like this shell that people say look like Jesus. Okay, or why people see a man on the moon, a face on the moon. Or while people look at these and they're like, oh my gosh, are those clouds or flying saucers? Well, my vision when I think of a cloud, I think of like the billowy, puffy ones, right? Or even like the wispy, drawn out ones. But when I think of a flying saucer, I think of like a disc shape, right? And this looks like a disc shape more. So when this happened to some towns, they were like, are we being invaded by aliens? No, you're totally not. It's a cloud because logically, like, yes, it'd be a cloud in the sky. They just look weird. But these clouds can appear, but people freak out because their schema more closely matches a flying saucer. So all of this stuff goes into us having a predisposition to see or hear or feel a certain way about certain things because we have a perceptual set about it. So this fits into subliminal stimulation. People have asked, what's the difference between this and absolute? Absolute is the minimum amount of stimulation you need to respond to something 50% of the time. So that's like the minimum level. Here's where we need to reach in order to have my body pick up on it. Subliminal stimulation is below. It's below the absolute threshold. It's below conscious awareness. But some people will say that, yeah, it's not consciously recognized, but unconsciously you pick up on it. So people tried this over and over. Like a newspaper reported that a theater put a subliminal message that said eat popcorn up during a movie, and popcorn sales soared. To be a subliminal message, it means it had to blip up on the screen so fast that your brain didn't even register it. Or it had to be whispered so soft through the speakers that your ears did not pick up on it because it was below the absolute threshold. Right? Came out that it was a total lie, and a TV show said, hey, if you watch our program tonight, we have a subliminal message that we're going to play on it. Let us know how, react, follow whatever it says to do. People called into the show and said, oh my gosh, I was so hungry during your show, or I had to go get a Coke, or whatever. Like, they had all these excuses, but it was about food. What it turns out is the TV show subliminal message had said, call our station, or it said, write us a letter. So to write our broadcasting center a letter about your experience. No one wrote a letter. Everyone did a phone call. So the thing is, through all of these trials, subliminal messages aren't real. They don't work because they're under the level of your absolute threshold. Your brain can't pick up on them, but yet people still believe they work. So sometimes the power of belief is really strong, but in the real world, they don't work. We're going to look with backmasking, the idea that people think that subliminal messages are hidden in records or like songs. If you play the song backwards, there's hidden messages and they can tell you what you need to do or what to believe in and all these other horrible things. But we'll look at them because they're pretty fun. So when we listen to them, just think about some of these questions. So we'll play with those today. But that's it for the intro for now. We'll go back to this PowerPoint and look at the lectures. But for now, I'm out of here and onto the eyeball.